Now we're going to practice drawing alkanes and cycloalkanes. Now this one is very simple, to be honest. So you just have to follow again 4 steps. Number 1 is to draw the parent chain or ring if you have a cycloalkane. Number 2 is to add the substituents. Number 3 is to add the hydrogen atoms. And number 4, wait, that's wrong. Number 4 is to check for accuracy. Let's start. Draw the structural formula of the compound 3-ethyl 2,2-dimethylhexane. Now take note, you are asked to do the structural formula of the compound. So you need to show the carbon atoms and the hydrogen atoms. So you start with drawing the parent chain. So you have hexane, which is 6, right? So you draw 6 carbon atoms and then join them with a single bond. Now the correct way of drawing it is like this. If you remember, we talked about the carbons having 109.5 degrees. So it should be like this. But to make it easier and for convention, we just use the straight line. We add the substituents. We start with 2,2-dimethyl. If this is my 1, I will have a methyl here and a methyl here. Or we can add them here, but in that case, your number 1 would be this one. So it's the same. Next, we add the 3-ethyl. So this will be number 3. And you have 2 carbon atoms there. Okay. Now remember, carbon is tetravalent. So meaning it can form 4 bonds. This is very important when attaching hydrogen atoms. In this carbon, I already have 1 bond, so it can only bond to 3 hydrogen atoms. So we write H3. Now, the correct way of writing it is like this, H3C, to show that this carbon is bonded to this carbon. However, again, to make it easier, I will accept this drawing. This one also has 1 bond, so this will be H3. So this one has 4 bonds, so no hydrogen atoms can attach to it, so we don't write anything. Here, 1 bond, so H3. Next, this carbon has 2 bonds, so you can have 2 hydrogen atoms bonded to it. This one has 1, so this is H3. This carbon has 3 bonds, so 1 hydrogen atom can bond to it, so we write H. We don't write 1. Next, this one has 2, so H2. This one is 2, H2. This one is 1, so H3. Okay, now let's check. So you have hexane. So you have 1, 2, 3, 4, 5, 6. So that's correct. Let's have 2,2-dimethyl. At carbon number 2, you have 2-methyl. So that's 1, 2, 2,2-dimethyl. Correct. Carbon number 3, you have ethyl. So CH2, CH3. Correct. Next, draw the line angle formula of the compound. Here you are asked to draw the line angle formula. In line angle formula, the vertices are carbon atoms and you don't show the number of hydrogen atoms. So let's start with the parent chain cyclohexane. So cyclo meaning this is a ring. Hexane, so it's a ring with 6 carbon atoms. So we draw this one, a hexagon. So if this is our carbon number 1, we'll have sec here, sec-butyl 1, 2, 3, 4. This is from the non-systematic names. Next, 2-cyclopropyl. So at number 2, you have a ring that has 3 carbon atoms. So you can either go here as 2 or the other side 2. So in this case, I'll go here. So I put a triangle here. Next, 4-methyl. So that would be 3, 4. So I will put methyl here. Okay, now let's check. Cyclohexane. 1, 2, 3, 4, 5, 6. Correct. 4-methyl. 1, 2, 3, 4. 1 carbon atom. That's methyl. Correct. 2-cyclopropyl. 1, 2. Cyclo, it's a ring. Propyl, it has 3 carbon atoms. 1, 2, 3. 1-sec-butyl. Butyl, 4 carbon atoms. 1, 2, 3, 4. Okay, so that is correct. Next, draw the line angle formula of the compound 4-sec-butyl 5-cyclopentylnonane. So this is simple. It's a line angle formula. We start with the parent chain, nonane. So I'll draw 9 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9. Next, we draw 4-sec-butyl. So here at carbon number 4, again, sec-butyl is like this. Next, we draw a cyclopentyl. So it's a ring with 5 carbon atoms. So that is a pentagon. So we draw a pentagon here at carbon number 5. That's it. Okay, let's check. Nonane, 9, 5-cyclopentyl, 1, 2, 3, 4, 5. So at number 5, it has 5 carbon. At number 4, you have sec-butyl.